Hello and welcome. In this lesson, we will talk about the surface area and volume of pyramids and cones. Please recall that pyramids are 3D objects with only one base. If you look at this square base pyramid, the base is highlighted in blue and it is in a square shape, which is indicated by labeling the two consecutive sides of the base by the same letter B. Now remember that the word consecutive means next to each other. So consecutive numbers are numbers such as 2 and 3, 5 and 6. Consecutive side lengths are two sides that are connected at a point. Now, the base of a pyramid can be in any polygonal shape. In this case, we have a square, but it could have been a triangle, a triangular base pyramid. It could have been a rectangular base pyramid, a pentagon, so pentagonal shape or base pyramid, etc., etc. Now, another very important measurement in a pyramid that determines the size of a pyramid is its height. The height is indicated by this green line, and it shows the distance of the vertex of the pyramid, which is the highest point on the pyramid, from its base. And it is always indicated by letter H. The lateral faces of a pyramid are in triangular shape. And that will be the case in any type of pyramid, no matter what the shape of the base is. So let's write this down here. Now, I want you to take another look at this diagram and think, how many lateral faces would this pyramid have? Now, since the pyramid has 4 sides at the bottom on the base, it's going to need 4 lateral faces, right, to close up the shape because it's a 3D shape. Now, I hope that this letter S in here got your attention already. And not sure if you remember the name of it, but if you look at S, it's used to describe or to label this side. Okay? Now, this is the height of the triangle that serves as a lateral face on this pyramid. Now, since this is a height, why did we use the word S for it? As a matter of fact, this particular measurement has a special name and a special role in the pyramid. So we call this the slant of the pyramid. So the slant of the pyramid is nothing but the height of the triangular lateral face. So let's write this down here. The surface area of the pyramid is the total area of the base and the triangular faces or the lateral faces. Now, to determine the volume of the pyramid is very similar as when we determine the volume of a prism. It will always be area of the base times height, but this time we take 1/3 of the product of area of the base with height. Now remember that for the area of the base, we have to consider the shape of the base. So if it is a square, then the area of the base will equal b squared. But if it is a triangle, we have to use the area of a triangle formula. If it is a more complicated polygon, then we have to break down the polygon into smaller shapes and find the area. Now, the net diagram of the pyramid is quite easy to imagine and simple, and It would be interesting if you would make a pyramid out of paper, and if you fold it out, you will see that the net diagram of a pyramid is made of the base right here in the center, and attached to every base will be a triangle, which is the lateral face. Now, the net diagrams are most commonly used to help us visualize and understand how to find the surface area of a pyramid. Now, since the pyramid, according to the net diagram, has the base, which I'm going to call by letter A1 here. Let's make it blue since we made the base blue before. Then the area of each triangle can be represented by the same letter. So if I were to put this in a formula, then I would write that area would equal A1 plus 4A2. Now, since the area of the base is B squared, because it's triangle, and the area of each lateral face would equal B times the slant divided by 2. Then we're going to say that the total area would be equal to area of the base plus the areas of the 4 triangles, or B squared plus, and you're probably wondering where 2BS comes from. So remember that the area of one triangle was B times S divided by 2. But when we take 4 times of this area, then the 4 and the 2 will simplify to give the number 2 that you see before the product B times S. Now let's move on to the next shape for today, a cone. Now a cone is a 3D object with one base, just like the pyramid. But this time, the base of the cone will not be polygonal, but it will be circular, unlike the pyramid. Now, the lateral face of a cone is in a very interesting shape, and it has kind of a unique name that you might or might not have heard of. We call it a conical shape, but it's a very easy word to remember, even if you've never heard of it, because you think of a cone, and a cone is a conical, right? So the size of the conical shape, or the lateral face, is measured by the slant. So here is the slant again. The slant, remember, in a cone would be the length of the line that connects the highest point of the cone with any point on the circumference. The surface area of the cone is the area of the base and the area of the conical lateral area. So remember that if we were to find the surface area of a cone, we would have to consider the area of the base, which is a circle, and the area of the circle is measured by the formula pi r squared. Now, the area of the conical shape, as you can see in here, would be determined based on 2 measurements. So recall that this would be the slant. The bigger the slant, then the bigger the area of the lateral face is. Okay, so try to imagine the slant getting bigger and bigger and bigger, which means the cone getting taller and taller. So that will increase or decrease if it is smaller, if it were to be smaller, or decrease the lateral area of the cone. Now, another measurement that determines the size of the conical area, lateral area, would be the circumference of the base. Remember that the conical area is wrapped around the circular base, right? And it fits exactly the same, it fits exactly the perimeter of the base, which means that this size in here will be determined on the size of a circumference. The bigger the circumference, the bigger this size in here, okay? And a bigger circumference will happen for bigger radius, okay? Now, let's take a look at some examples where we can use the formulas that we just discussed together. In example number 1, we are given a pyramid and we have to draw the net diagram of it. As you can see in here, we have these short little lines which indicate that the base of this pyramid must be a square. It is very important that whenever we solve a problem in geometry, we examine the diagram closely. And once we understand the diagram and the information given, then we can solve the problem faster and more easily, and it will be more fun as well. So, if I wanted to find the surface area, then I would have to consider that the base is in a square shape, and it also has the 4 lateral triangles, which will serve as the lateral faces. So let's try to make them equal. So this is my strategy when I want to actually build symmetrical pictures or diagrams. So I try to find a point first, okay, and then I aim for that point. I hope this is close enough. All right. Not perfect, but close enough. I think that this triangle can use some TLC here. Here we go. So let me put this point here. Okay. Now, this is a net diagram. And what we do see in here is the area of the base, which measures 5 by 5, and the areas of each triangle. So see that here we are given the side length, this red side in here, which connects the top of the pyramid with the middle of the base. So I want you to think about it. Would this be the slant or the height that is given? So this would be the slant of the pyramid, which I will draw right here. Now the slant of the pyramid will help me to find the area of each lateral face. And it seems that the slant here is equal to 5. And it seems that this net diagram is not to scale now, but the shape is there and the idea is there. Now, if we want to find the surface area, then we're going to say that we will need to know the area of the base plus 4 areas of the triangular bases, lateral faces. So, area of the base, since it is a square, is 5 times 5, or 25. And then we have 4 areas of a triangle. So one of the triangles will have the area base, which is 5, times height. Remember, the height of the triangle is the slant of the pyramid divided by 2. And let's calculate everything. So we have 25, and then plus, and here we go. We have 4 and 2, that's simplified to 2. 2 times 5 times 8. 2 times 5 times 8 is 80. So we'll say that the surface area of this pyramid is 25 plus 80, or 105. So I'm going to say that, here we go, we found the surface area, and I'm so happy, and I'm thinking, have I forgotten anything here? And you're probably saying to yourself, yes, you have forgotten something very, very, very important, which is the unit measurement. So the unit measurement would be unit squared because it's area, and since we're using centimeters, centimeter squared. So here we go. I will fix this, and I will pretend I never made that mistake. All right, so another question asked in here is to find the volume of the pyramid. And why don't I move this one under the net? So we organize our solution. Now, to find the volume of the pyramid, we're going to have to use the volume of a pyramid formula. So that would be 1/3 of area of the base times the height of the pyramid. Now, can you see the height of the pyramid? Well, first of all, what is the height of the pyramid? The height of the pyramid, remember, connects the top of the pyramid, the highest point, with the center of the base in here, because it is drawn perpendicular to the base. And since the base is in a square shape, it means that the height of the pyramid will drop exactly in the middle of the shape. So I'm going to draw the height first, somewhere in here. And the height will be perpendicular to the base of the pyramid. Now, we don't know what the height of the pyramid is because we're not given the height. But what we do know is that it will fall exactly in the middle of the base, which is a square-shaped pyramid. So what we are going to do is we are going to connect the leg of the height with the leg of the slant together. And when we do this, then we create a right angle triangle. So try to imagine this. So we have a right angle triangle, and the right angle is right here at the leg or at the bottom of the height. Now we know that this slant in here is 8 centimeters, and the slant will be positioned opposite the angle 90. So that will make the slant a hypotenuse. Now, we need another measurement. If we're looking for height, we need another measurement, and that would be this side in here. Now, I want you to think of what would this side length be. Remember that this perpendicular was drawn right in the middle, in the center of the base. So if this length was 5 centimeters, so here we go. This is 5 centimeters. This is 5 centimeters because they're all 5 centimeters, right? Now, when you draw the perpendicular, then you have fallen right here in the middle of this side, which should be the same as half of this. So this would be equal to 2.5 centimeters. So now that we have the two sides in this triangle, we can use the Pythagorean theorem to find the height. And we're going to say that, let's make the height green, and we'll say that the hypotenuse squared would equal 2.5 squared, and then plus height squared. Now, the hypotenuse, is 8. So we can substitute that by 8. So therefore, we'll have in here 8 squared, or 64, equals 2.5 squared, I think is 6.25, plus h squared. So 64 minus 6.25 would equal h squared, and that will make h squared equal to, so the way I subtract this in my head is 64 minus 658, but then take away 0.25, that's 57.75. So that means that h equals the square root of 57.75. So I will leave this in this form, 57.75. I won't calculate it with a calculator or round it, and I will move on to the volume formula, or move back to the volume formula and say, okay, now I think I have everything I need to find the volume. Area of the base would be 5 squared, because it's a square, times the height, which is the square root of 57.75. And for this, I'm going to use a calculator. So if it makes more sense to you, you can also write this as a single fraction with number 3 at the bottom. And on top you have 5 squared, or 25, then root 57.75. And let me grab my calculator. Here we go, we have 25 times 57.75 square rooted is divided by 363.3. Think again, what units are we using? Centimeters. What are we finding? Volume. So that's cubed. So that would be the answer. Now we have one more example that I want us to look at. And I hope you have all the energy and the enthusiasm to listen to one more example. This time we are looking at a cone, and we are given this beautiful cone here. We have to find the height of the cone first, and then find the surface area and the volume. So I am going to keep the formulas handy in here. So for the surface area, I know that I have to use the formula pi r squared, that's the area of the base, plus pi r s, which is the lateral area. For the volume of the cone, I know that the formula is 1/3 pi r squared h. And it seems that in this case, I am not given the height of the cone, and I must find that first. So I'm going to get started with the height of the cone. So question A, answer A. It's very important to organize your solution. First, I like to draw the height. I want to see what I'm trying to find in here. And then I'm going to check and see what the height means to this diagram. And what I see that it means is that if I looked at this diagram and made this triangle here, which is a right angle triangle, then I will know how to find height by using the Pythagorean theorem. So h squared plus 5 squared equals 13 squared. So remember, this will be the hypotenuse because it's 90-degree angle right here, and they're across from each other. So hypotenuse is always across the angle 90. So here we go again. We have h squared equals 13 squared, which is 169, minus 5 squared, which is 25. I hope you don't mind when I kind of skip the steps. So instead of evaluating first and then taking this to the other side, I just evaluated 13 squared to 169, and I took 25 to the other side, which is a step you can skip in grade 9. So we don't have to show the steps, but again, show as many steps as you feel it makes you feel confident. So there is no long or short way. So the best way is the way that makes more sense to you. So 169 minus 25, that's 144. And that will make h equal to the square root of 144. And square root of 144 is 12. So we simply square root both sides. So we got h, everyone, which makes us feel accomplished. Now, have I forgotten anything here? Oh, unit measurement. So let's write this down. Now, the next question, question B, is asking for the surface area. So here goes the formula. Always start off by writing the formula. It's a good guiding point, and most of the time is given to you. And pi r squared, at least in EQAO. And pi, we're talking about this r in here, times 5 squared, plus pi, we're talking again about the same r, 5 times 13. So that would be 25 pi, and then 5 times 13 is 65 pi. So many pi's, so 90 of them. So that would be the exact answer for surface area, actually, if we wanted to live in exact form. And I'll give it unit measurements, centimeters squared. But if you would like to see the numerical value of it, you simply use the calculator and you multiply number 90 by the constant pi. I usually like to use the pi in the calculator, but you may as well substitute pi by 3.14. That is totally acceptable as well. Always remember the operation between these two is a multiplication, right? So what I got in here is 282.7. And again, I won't forget the unit measurement, centimeters squared. And I'm done with surface area, which means that I've answered question B. Now the next question is finding the volume. And for the volume, we're using the formula V equals 1 over 3 pi r squared h. So 1 over 3 pi, r is 5 squared, and h is, we found out it to be 12. So that would equal 12 over 3, 4. So we have pi times 25 times 4. You can do this in the calculator very easily. So that is like 100 pi. Now, this would be the exact value of the volume, and unit measurement will be cubic, so centimeter cube. Exact value. And here we had exact value as well. Since we are talking about exact values. And if you want to find the numerical value, I mean, if you want to see the number, then we multiply 3.14 by pi, or 3.14 by 100, 100 times 3.14, or by pi is even better. And what I get in here is 314.2 centimeter cube. And this would be the approximate answer. So this was the lesson for today on volumes of pyramids and cones. And the things that we focused on were the wording or the language we use in describing these shapes. So for pyramids, remember, we needed to know the measurements that will help us find the base. Depending on what type of polygonal base we have, we're going to need different values. Slant is very important to determine the size of the surface area, and height is a very important number to determine the volume of the pyramid and the surface area. And for a cone, The surface area may be a little bit tricky to memorize, okay? Not difficult. And a cone has a slant, just like the pyramid. And the volume of a cone is found in a similar way as the volume of a pyramid, so 1 over 3 pi r squared h. And whenever you finish learning a new lesson, always go over the new exciting things that you learn from that lesson, because that will make it more memorable, and that will prepare you even better to practice your homework and learn more new things. I hope you enjoyed the lesson, and I hope everything made sense. Thank you for watching. Bye for now.